Okay. So now we want to use bootstrapping to produce a histogram of resampled means from this station 70 start. So what that means is that we're going to go to this table. It's got 800 rows, right? And each time we're going to, so we're going to do this, the following operation 500 times. We're going to resample the table with replacement, which means that some of these trips will get picked multiple times and other trips won't get picked at all for our new table. But the new table will also have 800 rows, and then we'll compute the mean duration for that new table, right? And we'll do that operation 500 times and look at the array of means, and then we should be able to make a table of means and then plot this histogram of the 500 means. So, okay, so the first line here is just setting a random seed, nothing too special. And then the next line is making an empty array to store the means. I'll call that mean array. And then we're going to do 500 resamples. And in that and then we're going to run this indented code 500 times to each time produce a mean and put it into our mean array. So first we go to our table, station 70 start, and we sample it with replacement equals, which replacement already is there. And we want to have with replacement true so that sometimes we select rows multiple times and sometimes they don't get selected at all. This is really important for bootstrapping, that with replacement is set equal to true. If you had with replacement equal false, it would just shuffle the rows. And then the mean would always be exactly the same number every time, right? And that's not what we want in this case. So the new mean will just be the mean of this resample table that we just constructed, the mean of their duration numbers. And then we will take our mean array and tack on the new mean onto the end using the npappend command. Okay, redefine the mean array. And so each time through this loop, there's a new mean that's being added to the mean array. And when we're done, we have a mean array with 500 values in it. And then we just make a table with only one column called means, and have and the entries in that column are the values in mean array. Okay. And we make a histogram of the means from the mean table, and we have to look up and see what we want for the bins. The bins should start between 600 and 1300, spaced 10 seconds apart. So the starting number is 600. The stopping number goes here. The displacement goes here, 10 seconds. And if I put 1300 here, it'll stop just before 1300, and I won't get the number 1300. But if I put any number bigger, it'll stop at 1300. So 1301 is fine. 1310 would have been okay as well. This code might take a tiny bit of time because it's doing 500 iterations through the loop, but not too bad. Okay, and let's just compare this to the picture. Looks pretty good. Okay, cool. So just glancing at this, it looks like possible numbers that there could be for the mean duration look like numbers from about 690 maybe to 920, right? Seems like those are kind of plausible ranges for means that you could get. Some of them are more obviously common than others. And let's compute a 95% confidence interval and a 99% confidence interval. Okay. So for a 95% confidence interval, I'd like to look at the middle 95% of these means and use those values as my values in this interval. So what we could do is a 95% confidence interval is missing 5%, right? And that 5% gets split on the bottom and the top, and then you just use the percentile command to find the 2.5 percentile, half of 5%, for the values in the means array. So means array is the array of all the means, or we could go into the mean table and get the column of means, but it's also giving us the mean array. Is it called means array or mean array? Mean array, sorry about that. And then the right endpoint is percentile 97.5 mean array. And I say do the same thing for the 99% confidence interval. What should I be typing here for the left endpoint for the 99% confidence interval?
0.5.
Good. So it's the percentile 0.5 mean array. So 99% confidence is missing 1% confidence, and you split it on the bottom to get half a percentile, and on the top get 99.5 percentile. Cool.